Okay, so today we are discussing about the chapter name called as motion in two dimension. In that we'll discuss about a subtopic that is boat and river. Okay, so we shall discuss about the concept of a river boat. It's a two-dimensional concept here. We shall discuss about the relative velocity of a boat with respect to the river here. It's a very easy and very interesting topic. Let us discuss about that here. So for discussing that, let us go for first of all we shall discuss about what is the meaning of shortest path. First we shall discuss about what is the meaning of shortest path here. So let us draw one small diagram here. This is a diagram which I am drawing. Let us imagine this is a river here, a river. This is a river. Now, if you are considering this river, and in this river is flowing towards right, river is moving towards right, and now let us imagine you are present here at this point, point A. If you are present at this point, and your aim is to cross and reach the exactly opposite point here, okay? So you have to reach the opposite point here, that is opposite bank of a river. Now what are you going to do to reach there? You have to reach the opposite point in exactly shortest path. So for that, what are you going to do here? In a shortest path, you will reach here. That means you have to move exactly perpendicular to the direction of the river here. Then exactly if you move perpendicularly, then you will reach exactly opposite point of the river. Okay, so we shall discuss here the concept. So when you aim exactly opposite point, which is called as B here, what you have to do? Already river is flowing towards right. Already river is flowing towards right. So as the river is moving towards right, if you aim your boat in this direction, then definitely I can tell that your boat is not going to reach upwards exactly at B. The river which pushes the boat and makes you to reach in this direction. Okay, so the river flow will affect the motion of a boat, the direction of a boat also. Then what are you going to do now? What are you going to do to overcome this effect of river? So you need to exactly aim opposite, but your boat should move with certain angle in this direction. So if you place your direction, if you place the direction of the boat here in this direction, so then what are you going to do? This river will make the boat to move in this direction now. Okay, so what I'm going to say here is, if you want to reach the opposite end of the river, exactly opposite point of the river, that is the other bank of the river, then your boat should have certain angle with the vertical now. But here the river flow will take your boat exactly to the opposite point. This is considered to be angle theta here. Okay. So if you want to reach B point, you have to keep your boat in this direction. But as your boat is trying to move in this direction, but the river flow will push your boat, and even though the direction of the boat is like this, the boat will not move in this direction, but it will move in this direction here. So that is the meaning here. Why is it so? Because a river will flow towards right and make your boat to reach exactly opposite end. So once again, let me repeat. If you place your boat in this direction, the river will push it and take it to the exactly opposite bank. But if you are placing your direction, the direction of the boat towards B, the river will push it and take it to the other side here. It will reach here. But our aim is to reach the opposite bank of the river in a shortest possible path, which is exactly opposite here. Okay. So width of the river, this is called as the width of the river. You can take it as a D. So this is going to be the width of the river. We can take it as a D. Okay. So this is width. Then if you want to reach exactly opposite point of the bank, then you have to keep your boat in this direction. River will push it and make it to travel and make it to reach exactly opposite point here. So this is the point where your boat is aiming now, but it will not reach here. It will reach in this direction. And what is this? This is going to be the velocity of the river. Okay. So this direction will become the direction of the river here. So let us see what is going to happen now. Here, what is this going to be? This is going to be the resultant velocity of the boat. The boat, even though its direction is like this, the boat is not going to reach here, but the boat will reach the opposite point of the bank here, that is B. So now you will find out what is the resultant velocity. To find out the resultant velocity here, this is going to be 90 degrees and this is ABC. ABC is a right angled triangle. ABC is a right angled triangle now. Okay. So in this right angled triangle, you can write AC square is equal to AB square plus BC square here. So what is AC square? AC square is nothing but VB square. And what is AB square? AB square is nothing but the resultant velocity. That means actual velocity of the boat in this river. Or you can also write this is velocity of a boat with respect to river. Also you can write here. So we can write, let us write like that only. This is going to be the velocity of the boat with respect to river. Plus what is BC square here? BC square is going to the velocity of the river whole square. Okay. So this is an actual boat velocity. So what is the meaning of actual velocity of the boat here? That is velocity of the boat in still water. We can say VB is nothing but velocity of the boat in still water. That means the river effect, if you don't consider, what is the actual velocity of the boat? That is considered to be VB here. And velocity of the river is considered to be VR. Velocity of the river is considered to be VR here. And what is this? This is velocity of boat with respect to river. Understand? It is not the pure velocity of the boat. As the river is pushing the boat actually it moves in this direction. That is called as velocity of boat with respect to river. Then let us find out this velocity of a boat with respect to river is equal to velocity of boat whole square minus velocity of the river whole square. But you should remember one thing here, velocity of the boat should be always greater than the velocity of the river. That is the condition here. Your boat velocity should be always greater than the velocity of the river here. Okay. So why is it so? If your boat is having lesser velocity compared to the velocity of the river, definitely your boat never reaches the other end because its velocity is less compared to the river velocity. Your boat, if it tries to go also, as its velocity is lesser than the velocity of the river, it will flow along with the water, but definitely it doesn't reach the opposite end of the river. So to reach the opposite end of the river, definitely your boat's velocity should be a bit larger than the velocity of the river. That's the condition here that you have to remember. Then here if you draw like this, if you write the next step here, then velocity of boat with respect to river is going to be velocity of boat whole square minus velocity of the river whole square. So you got the velocity of boat with respect to river as VB square minus VR square, which can also be called as effective velocity, or it can also be called as resultant velocity of the boat in this direction now. So we got this one here. Then after that, what are you going to do? You need to find out how much time the boat will take to reach the opposite end. You have to find out now how much time it will take to reach the opposite end. Okay, so time you have to find out. To find out the time here, what are you going to do here? You all know that time along shortest path, we can say. Time along the shortest path, that is time along AB if you want to find out. That is the shortest path here. That can also be written as time along the shortest path. So time along the shortest path is nothing but it is distance by velocity is the general formula here. Distance by velocity or displacement by velocity. You can take displacement or width. The width of the river also you can consider. So you can write the general formula displacement by velocity. So time along the shortest path is nothing but displacement if you consider here. That is going to be AB. AB is going to be the displacement. And what is the velocity? Velocity is going to become the resultant velocity, or you can also write the velocity of a boat with respect to river. Velocity of boat with respect to river. So time along the shortest path is going to be AB by VBR, whereas VBR is going to be VB square minus VR square. So we got time along the shortest path as AB by square root of VB square minus VR square here. So we got the time along the shortest path here. The next thing is you need to find out what is the direction of the boat. How can you find out the direction of the boat? Direction of the boat, you can write like this: direction of the boat with the vertical. With the vertical. So direction of the boat with the vertical. So that is going to be angle theta. You need to find out what is this angle. So what is the meaning of this? How much your boat should be tilted. What should be the angle of your boat with the vertical, so that your boat will reach exactly the opposite bank of the river along the width of the river, which is going to be the shortest path. So shortest path is nothing but the perpendicular line drawn from this path to that path here. Though this is the perpendicular line, that is going to be the shortest path here. So as you want to reach the shortest path, your boat should be tilted in this direction. If you want, we can take the direction of the boat also. This should be the direction of the boat here. This is the boat. Okay, it should make certain angle with the vertical, and we need to find out what is that angle here. How are you going to find out that angle? So it's very simple. To find out the angle here, what you have to do. Okay, so what are the things we know? We know velocity of the boat and velocity of the river. You know the boat velocity, you know the river velocity, but you don't know how much velocity is the boat taking to reach the opposite end. You don't know the resultant velocity. Resultant velocity of the boat with respect to river, you don't know directly. You have to find out by using VB and VR here. So directly, what are the values you know? You know the velocity of the boat because you are going to row the boat. You know the velocity of the river because you are going to see the river with how much velocity is moving. Okay, so now let us see what is going to happen. So as we know VB and VR, what is the meaning? You know opposite end and hypotenuse. You know VB and VR. You know opposite end and hypotenuse. As you know opposite end and hypotenuse, you can apply sine theta here. You can apply sine theta. Okay. So if you apply sine theta, how much you are going to get here? So if you apply sine theta, it is nothing but opposite end is VR and hypotenuse is VB. So you can consider theta is equal to sine inverse of VR, opposite side, by hypotenuse. So this is the method to find out the direction of the boat. Okay, so you can find out the direction of the boat also along the shortest path. Okay, so we got these values now. If you understood this one, you can take a screenshot of this. And there are many methods to find out the time along the shortest path. Let us consider here to find a time along the shortest path. First thing you can find out is you can consider the distance AB and velocity VBR. If you know velocity of boat with respect to river, that is this value, if you know, you can take AB by VBR. Or you can find out the time along the shortest path if you know BC, that is that distance. BC distance if you know, and you can apply velocity of the river also here. Okay, so BC by velocity of the river, this also will give you time here. If you want to take this velocity, you can take this distance also, BC. And what is BC actually? BC is called as a drift of boat. A drift of the boat we call it as. What is the meaning of drift of the boat? Drift of the boat is nothing but, even though boat is aiming point C, boat is not reaching point C. A boat is reaching point B. That is, it has been shifted from its actual aim. That is, C is an actual aim, but it is not hitting C. It is reaching B. That C to B is called as a drift of boat. We call it as a drift. It is the movement of boat which is shifted from C to B here. So you can write time as the shortest path as a BC by VR. Okay, or you can also consider time along the shortest path as AC. Okay, if you consider this path AC, you can consider VB. Okay, so distance by velocity is the formula for time. You can consider AB by VBR or BC by VR or AC by VB. Okay, so these are the formulas with which you can find out the time taken by the boat. Okay, along the shortest possible path. Now the next topic we are going to discuss is time taken time taken to reach the opposite end in the shortest possible time here. So how much is that we'll consider now. We'll find out that one here. So for that, let us see what happens now. So if you understood this one, we go for the next topic. So here, let me write here, time taken along the shortest path. Shortest path if you consider as SP. So time taken along the shortest path is nothing but, it can be considered as AB by VBR. VBR is nothing but square root of VB square minus VR square. And I told you, theta also you can find out, that is sine inverse of VB by VR. So whatever the values we got here, I am writing here so that we can compare now. Let us consider the next topic here, that is called as shortest time. Shortest time. Now the second topic which I am discussing here is, our aim is to reach the opposite bank of the river in a shortest possible time here. For example, this is the path of the river. This is the direction of a river. So river is flowing in this direction now. Okay, this is the river flow direction. Now our aim is, you are considering this point as A and you want to reach the opposite bank of the river. Now you are reaching the opposite bank of the river in a shortest possible time. Previously, shortest path was your aim. Time was not your aim. Time you didn't consider there. Your aim was to reach the opposite bank of the river in shortest possible path. Okay, so that you got it. But now the second concept, my aim is not the path. My aim is to reach the opposite bank of the river in a shortest possible time. Then what you have to do? You have to take the help of the river now. You should take the help of the river so that you can get a promotion. You can get a push off. You can get push from the river so that you can reach the opposite bank of the river in a shortest possible time. So you have to consider the help of the river now. You should take the river as your helper so that you can reach the opposite bank of the river in a shortest possible time. Okay, so what are you going to do? Here in this case, you are going against the river. You are going a little bit against the river, but your aim was satisfied. That is, you are reaching the opposite bank of the river in a shortest possible path. But now your aim is not the distance, not the shortest distance. Your aim is the shortest time now. So to reach in the shortest time, what are you going to do here? So your boat's direction will be in this way now. So you are trying to reach this way. Okay. So your aim is to reach the opposite bank of the river now, but not along the shortest path. Path may be long, but time should be short. Path may be little bit long, but time should be short. So to reach in a shortest possible time, let us take the help of the river now. You have to take the help of the river here. So now this is going to be the actual direction of the boat here. Your boat is trying to move in this direction. But as the river is flowing in the direction from left to right here, your boat will reach the opposite bank of the river in this direction now. This is going to be the path of the boat to carry it. So now your boat will reach in this direction. So this is going to be the resultant velocity, which can be considered as velocity of the boat with respect to river. So velocity of both with respect to river, because river will take your boat to the opposite point at this place. Okay, so this is B here, this is C now. And what is the angle? This is going to be the angle here. So what I am going to say is, even though your boat is trying to move in this opposite direction, but the river will take your boat to point C here. Okay, now this is the actual path of the boat now. Even though boat is trying to move in this direction, the river will make your boat to move like this. So your boat's aim is B, but reaching point is like this, that is C here, because river will push it to move in this direction. But now if you observe, a boat will reach in a lesser time to point C, because your aim is to reach the opposite bank of the river in lesser time, not in lesser path. So time will be reduced here. How time is reduced, I will prove now. So you all know here that triangle ABC is a right angle triangle as it is in the previous case, but you can write AC square is equal to AB square plus BC square. What is AC here? AC is going to be velocity of boat with respect to river whole square, and AB is nothing but VB square plus BC square. BC square is nothing but velocity of the river which you have considered here. So this is going to be the velocity of the river. Now velocity of boat with respect to river is going to be VB square plus VR square. Okay, so this is velocity of boat and velocity of river, and this velocity of boat and velocity of river has been written here. So previously if you observe, what is the difference? Okay, I told you this is going to be the resultant velocity now. This is going to be the resultant velocity. So if you observe previously, this is a red colored box. Resultant velocity previously it was VB square minus VR square. But here if you observe, resultant velocity along this direction will become VB square plus VR square. So velocity is this one. Velocity is increasing now. Here previously boat and river was subtracted. Here boat and river is adding now. Squares of boat velocity and river velocity is adding up here. So what is going to happen? Let us see now. So next point which we need to discuss here is you have to find out the time along condition, that is shortest time condition. Time along shortest time. Okay, shortest time. Your aim is to reach the opposite bank of the river in a shortest time now. So how are you going to find out the time here? So time is equal to time along the shortest time condition. So that is going to be, now in this case it is going to be AC by VBR. Okay, so previously it was AB, but now it is AC. But here if you observe, AC you'll write like that only, whereas VBR you'll write VB square plus a VR square. Okay, so this is the concept here. So otherwise you can write one more step here. You can take this as, this implies that, okay, so you can write one more step. Time along the shortest time is nothing but AB by square root of VB square plus VR square, whereas time along the shortest path is considered to be this one here. So you just see these two cases now. There you will get an answer. There you will understand here. Here denominator is subtracted. Here denominator is adding, squaring and adding. Here squaring and subtracting. So if you compare these two fractions here, definitely you will get an idea that here AC you have to consider here AC. Okay, because we are going along the path AC, that's why AC you have to consider. But if you observe the denominator, see AB and AC doesn't have that much problem here because almost they are hypotenuse and adjacent side. But if you observe the denominators, there the difference is denominator here subtracted, here denominator gets added up here. So what you will understand from this? So time along the shortest time is much less compared to time along the shortest path. Why is it so? Because here denominator is less. Denominator is less means fraction will become more. That means in this case along the shortest path it will take more time compared to the shortest time case. It will take lesser time here because denominator is adding up. When denominator is large, fraction will become less. So this is the case for shortest possible time here. Okay, so but you will get one more idea. Sir, why are you going in this direction? If you go in this direction, you are taking the help of the river, which is flowing in this direction. Definitely you are taking the help of the river. See, you may get crazy. Why don't you take the more help of the river and try to move in this direction? Then river will help you more to go very fastly. But just remember one thing. If you try to aim in this direction, the river will flow and there is a possibility that your boat may reach in largest time here. time may increase in this case. So our aim is we should not increase the time. So best condition is you aim the boat exactly opposite end but reach the different end. Okay. So what is this BC called? As here also BC is called as a drift of boat. We call BC as a drift of boat. What do you mean by drift here? A drift is nothing but how much the boat has been shifted from its actual aim. Its actual aim is B, but it is reaching C. That is called as a drift of the boat. I think you understood here. So we got the time now. So next thing, what are you going to do here? You need to find out how much direction the boat is tilted. How much is angle theta? So we need to find out the direction here. So how are you going to find out the direction here? It is very simple. Okay, so to find out the direction here, what are the known physical quantities? So we know, okay, known quantities are VB we know because we are rowing the boat, boat's speed we know, and also we know the river speed because we are seeing there, but we don't know what is VBR. We will come to know only after reaching there what is our speed. Okay, by taking the time. I mean, by taking the stopwatch, you can calculate how much time you are reaching. So, velocity of boat with respect to river, we doesn't know. We have to calculate it here. We have to calculate it. But ready-made values are, we know the velocity of the river, we know the velocity of the boat. That means we know opposite side, we know adjacent side. So definitely we can apply tan theta here because opposite side and adjacent side are known things here. So to find out the angle, we need to apply tan here. Previously known things are VR and VB same. But previously VR was opposite side and VB was hypotenuse. So opposite side and hypotenuse means better to apply sine there. But here we know opposite end and we know adjacent side. Opposite side we know, adjacent side we know. So tan we have to apply. So tan theta is nothing but opposite side by adjacent side here. So in this way we can find out the direction of the boat. So therefore theta is equal to tan inverse of VR by VB here. Okay. So this is the method of finding theta here in this case. But how many ways we can find out the time here? We can find out the time in different ways. Like for example, you can find out the time by using this formula, that is time along the shortest time is, we can take this distance and you can take this velocity. You can take this distance, that is AC by, we can take VBR. VBR is nothing but under root of VB square plus VR square. And what is another formula to find out the shortest time? You can take this distance and the velocity of the river also. So whatever the distance you are taking, that velocity you have to consider along that direction now. So what is the next formula to find out the shortest time? We can consider even here BC if you know, and you know velocity of the river, then also you can find out the time, because the time taken by the boat to reach from here, time taken by the river to reach from here to here is same, because both are same here. Time taken by the river to reach from here to here is same as the time taken by the boat to reach here to here. Okay, so you can consider, if you know velocity of the river and this distance, that is called as drift of the boat, then you can write BC by VR you can apply, or you can also take this distance, that is AB. If you want to take this distance, if you know what is the width of the river, this is called as width of the river. If you know the width of the river and if you know the velocity of your boat in still water, that means actual velocity of the boat if you know. Okay, this is not the pure velocity of a boat. This is the velocity of a boat with respect to river flow. Okay, so then we can apply this as AB along this direction AB. You can write VB also. Okay, so these are the three formulas with which, with the help of which we can find out the time here. Okay, hope you have understood shortest path and shortest time here. Okay, we shall apply some problems also. We can solve from problems also based on this in the next class. Okay.